Okay, so on to question number 4. Consider the ion HCO3. Draw the Lewis structure, label all the formal charges, write all the resonance structures, and label the hybridizations on both the carbon atoms and oxygen atoms. And what are the electronic shape and the actual molecular geometry around the central atom of this ion? Okay, so this question has multiple steps. So first, we just need to write out the Lewis structure. This will help us answer all of the questions. So we need to calculate the total number of valence electrons for this ion. Hydrogen has 1 valence electron, carbon has 4, and oxygen has 6. And since there are 3 oxygen atoms, we multiply this by 3. And also notice that the overall charge of this ion is -1, so we need to add an additional electron to this count as well. So if we count out how many electrons are in how many valence electrons are in the structure, we get a total of 24. Okay, so now let's try to draw out a plausible skeletal structure for this ion. We could have carbon as our central atom. And then I can draw single bonds to each of the atoms. So notice that carbon already has a full octet, but if I were to calculate the formal charges of all of these oxygens, they would all have a negative charge. So therefore, I know that my hydrogen would most likely be bonded to one of my oxygens like this, and that one of the oxygens will have a double bond. So let's draw the double bond here. And we'll verify that after drawing all of the electrons that we have the correct number of valence electrons, which is 24. So if we recall that each bond contains 2 bonding electrons, we have 1, 2, 3, 4, 5 bonds, so that's 10. And then counting out all the lone pairs, we have 24 in total. Okay, so this is a plausible Lewis structure for this ion. And we also need to label all the formal charges. So let me write the equation for formal charge up here. So formal charge is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So now let's calculate the formal charge of, let's say, the hydrogen atom. Hydrogen has 1 valence electron, and since there are no lone pairs on hydrogen, we write 0 non-bonding electrons. And there's only a single bond to hydrogen, so we write 2 bonding electrons divided by 2. We get a formal charge of 0. And let's do the same thing for the oxygen that has the hydrogen attached to it. There are 6 valence electrons in oxygen, and this oxygen has 4 non-bonding electrons, and there are 2 bonds to it. So we write 4 divided by 2, and its formal charge is also 0. For the double bonded oxygen, there are 6 valence electrons, 4 non-bonding electrons, and again 2 bonds to it, so we have 4 bonding electrons divided by 2. It's also 0. And for the single bonded oxygen, there are 6 bonding electrons, or valence electrons, and 6 non-bonding electrons, and only the single bond. So its formal charge is -1. So I can show that on my structure like so. And let's also just calculate the formal charge of the carbon, just so that everything is complete. Carbon has 4 valence electrons. There are no lone pairs, so it's 0. And there are 4 bonds to the carbon, so we have 8 bonding electrons divided by 2. So carbon's formal charge is 0. So the only negative charge is on our single bonded oxygen, and this is what causes the negative charge for our ion. So now we need to draw the resonance structures for this ion as well. And we have a hint that there are 2 structures in total. So pretty much the single bonded oxygen and the double bonded oxygen can be swapped. So we can have a single bonded oxygen at the top here with the negative charge, and the bottom oxygen can have the double bond. Okay, so these are the 2 resonance structures. And now we need to label the hybridizations on both oxygen atoms and the carbon atoms in one of the resonance structures. So let me write out on the side here the different charge clouds and whether or not they are sp, sp2, or sp3. So a charge cloud can be either a lone pair or a bonded atom. Let me label my different sections here. So this is part C, and this is part D, or being B. And up here is part A. Okay, so we know that a charge cloud can be either a lone pair or a bonded atom. So when we have sp3, this means that there are 4 charge clouds. sp2, we have 3 charge clouds. And sp, we have 2 charge clouds. So now we need to label the hybridizations of each of the atoms. So first let's look at the single bonded oxygen with the hydrogen. It has 2 bonded atoms and 2 lone pairs, so this makes 4 charge clouds in total. So this is sp3. And the carbon only has 3 bonded atoms. So the carbon is sp2 because it only has 3 charge clouds. Now let's look at the oxygen. It has 1 bonded atom and 2 lone pairs. So it's also sp2 because it only has 3 charge clouds. And for the single bonded oxygen down here, we have 3 lone pairs and 1 bonded atom. So it is sp3. And we can also label the ones up here as well, but it'll just be the same thing. SP. And now for part D, what are the electronic shape and the actual molecular geometry around the central atom of this ion? So if we pay attention to our central atom, which is the carbon, we can see that there are 0 lone pairs and just 3 bonded atoms. So if we use a Vesper theory table, this can tell us the molecular shape and electron geometry. So when we have 0 lone pairs and 3 bonded atoms, we have a trigonal planar molecular shape and electron geometry. I'm just going to write trigonal planar for both. Okay, so this answers all the questions, so let's see what the junior tutor said. They have the correct Lewis structure and drew out the resonance forms and labeled each of the carbon and oxygen atoms. Yep. And they found that according to the Vesper theory, they have a trigonal planar molecular shape and electron geometry. So this solution is correct.